let me share the screen. Okay, we will be
Yeah.
continuing the chapter periodic classification. Okay, for
Yeah.
CBS, for ICSE class 10th. All right.
Yeah.
Okay, is the screen visible to you?
Yeah.
Okay, so let's start. Our chapter is ICSE class 10th. Periodic classification of elements, which means we are going to discuss the periodic table. Okay,
Yeah.
now, so we know very well what are periodic tables, and in the previous class we discussed that what are called as the elements. Okay, so
Yeah.
what are actually elements? Kindly note down the definition. Elements, because we will be writing down the definitions as well in today's class. So what are elements? If someone asks you what are elements, then what you have to tell them? They are the pure substances which are made up of one type of atoms. They are pure substances made up of one type of atoms. Clear? What are elements?
Yeah.
I told you about
Pure
this.
substances.
Okay, what are the examples? Examples include carbon, sodium, okay, or we can say nitrogen, sodium, chlorine, etc. Okay, these are called as the elements. Then after that, what we discussed, this is just a quick revision of what we discussed in the previous class. Okay, we discussed about the Dobrnaya triads, we discussed about the Newland law of octaves, okay, where every eighth element beginning from any element resembles the first element in its physical and chemical properties. Clear?
Yeah.
Alright, now we will be discussing about the periodic table now. Now if someone asks you define periodic table, what is called as the periodic table? Define periodic table. So we know very well what is periodic table. It's a arrangement of
Yeah.
elements in a tabular form. Okay, arrangement of elements in a tabular form, and the elements are divided based upon the atomic numbers, based upon the metallic and the non-metallic character. Okay, and
Yeah.
in the periods and in the groups. That is called as the periodic table. Okay, so in this today's chapter in the periodic table, we will be seeing the trends in the periodic table, like what will happen when we will go down the group in certain properties, what will happen when we will go along the period, what properties will change when we will go along the period, along the group. Okay, so we will be discussing in this. So if someone asks you like what is a periodic table, what you have to define? You have to tell them it's a tabular arrangement. What kind of an arrangement?
Tabular.
Yes, it's a tabular arrangement of elements in groups. Groups means vertical columns. We know very well about it, right? Vertical columns.
Yeah.
What are groups? So we have a periodic table. Those vertical lines, those are called as the groups. Okay, and those horizontal lines, those are called as the periods. Okay, so a tabular arrangement of elements in groups, vertical columns, and periods. And periods, which are what? Horizontal rows. Horizontal rows, highlighting the regular trends highlighting the regular trends in properties of elements is called periodic table. Clear?
Yeah.
This is called as the periodic table. Now, we have discussed about what is called as the periodic table. Now we will be
Yeah.
discussing about the salient features of the periodic table. So we have discussed about this. Let us discuss one heading number third, that is what are the salient features of the periodic table. Okay,
Yeah.
periodic table. So what are the salient features of the periodic table? So periodic table we know very well, it includes the groups, it includes the periods. Okay, it has the groups and it has the periods. So if you look at the modern periodic table, okay, so first of all, the long form of the periodic table, we have the periods like this. This is hydrogen. Okay, like this we have a hydrogen. Then below this we have lithium. Okay, then we have sodium. So this is called as the what? This is called as group, right? We are going down the vertical line. This is group. Yes or no?
Yeah. Yes.
So then we will have potassium, rubidium, cesium, and then francium. Okay, like this. So I am writing the names here. Number one is hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Group number one. This is group number one. Okay, group number one. Then after that, so we call it as group 1A. 1A. Okay. Now from here, if you look from here, the period continues because these horizontal lines, this is called as what? Periods. Clear? This is periods.
Yeah.
These are the periods. Okay. Now what we can do here, see, here we will have what? Beryllium, then magnesium, calcium, strontium, barium, and radium. Okay, so now this is continuing like this. Okay, I'm writing here.
Yeah.
I'm writing here. So this is what? This is beryllium. Okay, this is beryllium, magnesium, calcium, strontium, then we have barium, and then we have radium. Clear?
Yeah.
So this is group 2A. We will call it as group 2A. Okay. Now here, now another group will start, but that will not be actually group 1A or group 2A. That will be group 3B. Okay, we will call them the group 3B because these are the transition elements. We will consider them in another group. Okay, this will be the group, but
Okay.
another type of a group, also called as the transition elements, P block. Okay,
Yeah.
so these are the S block elements which we have. This is called as the S block. Okay, the reason we call them as S block I will tell you later. So this is called as the S block. Clear? S
Yeah.
block. Now after that, group 3B, group 4B, group 5B is like this, it will be starting. Okay, so we will start from here, from calcium, then we have here. Okay, scandium, yttrium. Then from here to here we have the lanthanide series 57 to 71, and then 89 to 103 we have the actinide series. Okay, then
Yeah.
we have this titanium, zirconium, hafnium, and so on. Okay, so this will be considered as, so this was group second A, this will be group third B, because these are another kind of group. Okay, D block, this is D block, transition elements, third B, fourth B. Okay, it will continue to, like 7 are there actually, 10 are there total. So third B and fourth B. So if you will go like this, it will be 21 scandium, okay, yttrium. Then we have 57 to 71 as lanthanide series, okay, and then we have 89 to 103 actinide series, okay, 89 to 103. Okay, then afterwards we have titanium. So this will continue like this, titanium. Okay, I can't draw the whole periodic table, that is just for making you understand. Zirconium, hafnium, and rutherfordium, RF. Okay, so this whole periodic table will continue like this. The main purpose of for drawing this was to make you understand that these vertical lines, okay, this is called as the groups. Okay, while
Yeah.
these horizontal lines, this is called as what? Periods. Clear about this?
Yeah.
Now in this we will be discussing like what will happen when two certain properties of the elements, when we will go along the group, down the group, or when we will go along the period. Okay,
Yeah.
now just look at one thing. When we are going along the period, atomic number is increasing, yes or no? See, this is atomic number 1 hydrogen, atomic number 2 is helium, atomic number 3 is then lithium. So this is lithium is atomic number 3. Then atomic number 3 we
Yeah.
have atomic number 4, beryllium, right?
Yeah.
Beryllium. Now
Yeah.
just look here, we have this potassium, atomic number 19 potassium, then we have atomic number 20 calcium, 21 scandium, 22 titanium, which means along the period when we are going, atomic number is increasing. Okay,
Yeah.
atomic number increasing or increases along the period. Okay, along the period it increases. Clear?
Yeah.
Now let's move ahead. Let us discuss more about this periodic table. Okay, we will be considering this periodic table in a detail here. Okay, now, so these were the salient features which we discussed of the periodic table. Now actually we will be seeing like how how there will be the regular change in the trends when we will be seeing the periodic table. Okay,
Yeah.
clear? Now
Yeah.
let's discuss about the groups first. So how many groups are there? Okay, groups. So number first is the groups which we will be discussing.
Yeah.
Groups. In the previous class we discussed about the groups. Now also we will be discussing about the groups as well. So in the periodic table, okay, modern periodic table, okay, modern, because we are discussing modern periodic table in 10th class ICSE. Modern periodic table has how many groups? Can you tell me?
7.
18 vertical groups. Okay, 18 vertical columns, which are also called as the groups, also called as groups. Clear?
Yeah.
Any problem so far? And these are arranged
Yeah.
from left to right, arranged from left to right. Clear?
Yeah.
Okay, really very good. Now first we will be discussing about the particular group. So number first, group 1 elements. Okay, so inside the group 1 elements, let me open the periodic table as well so that you can understand. Okay, periodic element. So let us discuss about the periodic elements. Periodic table of the elements. Now just look here. Are you able to see?
Yeah.
Okay, so right now this is the group number 1: hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Right, group number 1.
Yeah.
So this group 1 elements, okay, these are called as the alkali metals. Okay,
Yeah.
they are called as alkali metals. Why these are called as the alkali metals? Because when they react with water, okay, they form alkalis. Okay, they form strong alkalis with water. Okay,
Yeah.
alkali with water. Clear?
Yeah.
These are called as the group 1 elements. Now next are the group 2 elements. Group 2. Okay, this is the group 1. Then we have the
Yeah.
group 2 elements. Now let us discuss about the group 2 elements. Now group 2 elements, what are the elements? Tell me.
Beryllium, magnesium,
Very good.
calcium,
Yes.
uh,
Okay.
I don't remember
Mhm.
what's under.
Very good. You are right. So basically, what are these? These are called as the alkaline earth metals. Clear? These are
Yeah.
called as what? These are called as alkaline earth metals. Remember the name. These are called as alkaline earth metals. Okay, why we call them as alkaline earth metals? Okay, because they are found inside the earth. Okay, and they also form the alkalis but weak. Okay,
Yeah.
as they are found in the earth and form weaker alkalis. Weaker alkalis. I will also show you with the help of the reactions as well. Don't worry. Alkalis and form weaker alkalis with water. Okay. Don't
Yeah.
worry. We will also see the reactions. You have studied these reactions in the previous classes. That is ninth class. But don't worry. We will see that again. Then we have from group 3 to group 12. Okay. So group 3 to 12. Clear? So groups
Yeah.
3 to 12. Okay, these are called as the transition elements. What these are called as?
Yeah. Transition elements.
Yes, these are called as transition elements. Transition elements. Now what do I mean by transition elements? Transition elements, which means they have the two outermost shells which are incomplete. Okay, that is, they have their two outermost shells incomplete. Incomplete. Okay, this is group 3 to 12. Now, group 13. I told you that from group 13. Okay, let me share you. From group 13. So this is called as the, so this was S block, right? This was S block, which we were discussing. Group 1 and group 2. It comes under S block, I told you. Then this is D
Yeah.
block, right?
Yes.
We discussed this, that this was the D block. And after that we have this part from 13 to 18. This 13 to 18 which you are saying, okay, which you are seeing right now, 13 to 18, this comes under P block. Okay,
Yeah.
this comes under P block. Later we will be discussing that why we are actually calling them S block, why we are calling them as P block, why we are calling them as D block and F block. Whatever is there we will be discussing, because for now, as you are just in 10th class, you haven't understood what are actually the subshells. You have just studied about the four kinds of shell: K shell, L shell, M shell, N shell, right? But you don't know what are the subshells like S subshell, P subshell, D subshell, F subshell. Do you know about that?
No.
No, that's why. So we will be discussing about this as well. But for now, we will be just discussing that what are the regular trends in the periodic table. What will be the change in certain properties inside this periodic table when we will go down the group, along the period, all of that. Okay.
Yeah.
Very good. Now from group 3 to 12, then we have group 14, or let's say group 13, because after 12 there is 13. So group 13. Group 13, this is called as the boron family. Okay. This is called as the boron family. Why it is called as the boron family? See, this is called as the boron family, group 13. Boron family.
Yeah.
Why it is called as the boron family? Just look here in this group. What is the first element in group 13?
Boron.
Boron. That's why it is called the boron family group. Okay.
Okay.
So boron family. So this is boron family. Why? Boron is the first member of the group. Then afterwards we have the group 14. Total how many groups are there? 18 groups. Group 14. Now, group 14 is called as the, tell me by which group? Carbon family. Okay. Carbon
Okay.
family. Why it is called as the carbon family? Just look at here. Because carbon is the first. Then we have the nitrogen family. Then we have the oxygen family. Okay, and this is also called as the chalcogens. Okay, ore forming. Then we have the halogen family. Okay, we will be discussing each and everything. So next one, group 15 will be which group? Group 15, nitrogen. Nitrogen family. Okay,
Yeah.
nitrogen family. Then we have group 16. It is also called as the oxygen family.
Okay.
Oxygen family. And this is also called as the chalcogens group. Chalcogens. Chalcogens. Okay. Then we have group 17. Group 17 is also called as what? Halogen group. What? Halogen group. Okay. Halogen group means fluorine, chlorine, bromine, iodine. See, fluorine, chlorine, bromine, iodine. Okay. So this is called as what? Halogen. Halogen group. Okay. Now,
Yeah.
clear about this?
Yeah.
Then last group we have, which is group 18. Which group? Group 18. Group 18 is what? Group 18 is also called as the zero group. Zero group. Okay, zero group. Why this is called as a zero group? Okay, because they consist of the noble gases. This group consists of the noble gases or inert gases. Consists of noble gases, or we can say inert gases. Inert gases. Clear?
Yeah.
This is group 18. Okay, why these are called as a noble gases? Because their octet or duplet is complete. They are actually with they only react when certain conditions are provided to them. Otherwise, they don't react at all. Okay,
Yeah.
their outermost orbit is complete and they have the stable electronic configuration, and they hardly react until or unless they are provided with extreme conditions. Okay, special conditions are not given to them. Okay,
Yeah.
now just look here. From group 3, this group was like group 3 to 12. This was a different group. We called it, okay, transition elements, right? But group 1 2, always remember, group 1 2, and then from 13 14 15 16 17, and the last one 18. These are called as the groups consisting of the normal elements. Okay,
Yeah.
we can call it as the main group elements. Main group elements, clear? Or we also call
Yeah.
them as the representative elements. Group consist representative element group. Clear?
Okay.
Very good. Now let's come to the periods. Ready about periods? Okay.
Yeah.
So number second is periods. The salient features. Inside the salient features we have the periods. How many periods we have? We discussed in the previous class 18 groups and
7.
7 periods. Very good. So there are 7 horizontal rows. Horizontal rows. Okay. Also called as periods. Clear?
Yeah.
In the periodic table. And what we see when we were going along the period, what was increasing? Tell me.
Atomic number.
Atomic number was increasing every time. Okay,
Yeah.
which means when basically we go along the period, atomic number will increase. Okay, which means when we will go along the period, so first period will have only one shell. Okay, second period will have two shells, third period will have three shells, and so on. Okay, for example,
Yeah.
first of all, let's say at period number 1. Let's take period number 1. So period number 1 has how many? I'm going to share you the table. So the atomic number 1 is hydrogen, and last one is what? Atomic number 2 is helium. See here. This is first period. 1 hydrogen, 2 helium. Okay.
Yeah.
1 hydrogen, 2 helium. Clear?
Yes.
So let's take first period. So first period, how many shells are there? Say in first period we have the hydrogen represented by the symbol He, H, and helium represented by the symbol He. Okay, its atomic number is 1, and this its atomic number is 2.
2.
Now, how many number of shells will be there? Only. Just write the electronic configuration. So, electronic configuration, K shell will only have the one. There is only one electron in the K shell, which means only K shell is there. Whereas in helium, electronic configuration is
2.
yes.
But yeah.
Only one shell is there and 2 electrons at most will be there. Okay, it's a noble gas. Helium is a noble gas, right?
Yeah.
Okay, complete duplet is there. Okay, that's the reason why a stable electronic configuration is there. So you can say that only K shell is there, right, in the first period. Now let's
Yeah.
this is the shortest period. Remember, first period is the shortest period, because only two elements are here. First period is the shortest period. If someone asks you what is the which is the shortest period, first period is the shortest period. Clear?
Yeah.
Shortest period. Then let's come to period number 2. Period number 2. Oh my god, I haven't shared this tab. See, first period is the shortest period. Okay?
Yeah.
So hydrogen, helium. See, atomic number is 1, atomic number is 2, electronic configuration, K shell has only 1 and K shell has 2 electron, but the shell is only 1 here, and this is the shortest period. Okay, number of shells, how many number of shells are here?
What?
Only 1, right? Clear? Now let's come to period number 2. Okay, so we have discussed about period, first period.
Yeah.
Now let's discuss about period second period. Okay,
Yeah.
let's discuss about second period. What do I mean by second period? Can you tell me? Second period means how many elements are here? Just look at this periodic table again. Second period. Tell me.
8.
Yes, lithium, beryllium, right? Boron, carbon, nitrogen, oxygen, and fluorine, and neon, right?
Yeah.
Second period. So how many elements are here? Just let me write.
8.
Yes. See, lithium, beryllium, okay, then boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, so atomic number will increase, right? These were the elements. So
Yeah.
atomic number 1 hydrogen, 2 helium, 3 lithium, 4 beryllium, 5 boron, 6 carbon, 7 nitrogen, 8 oxygen, 9 fluorine, and 10 neon, which means from 3 to 10 second period. And this is the short period. This is called as the short period. How many elements are here? 3 to 10. Okay,
Yeah.
1 2 3 4 5 6 7 1 2 3 4 5 6 7 8 8 elements are there total. How many?
Yeah. 8.
8 elements are here, and this will be called as what? Short period. Short period. Clear? This will be called as
Yeah.
short period. Now one more thing, just let me tell you one more thing here. Just write the electronic configuration of lithium. So lithium electronic configuration will be how much? Atomic number 3.
2.
So
Oh.
Kl 2 and 1. Then
Yeah.
number of electron will increase every time. Okay, so for beryllium it will be 2 2. For beryllium it will be 2 2, right? For boron it will be 2 3.
Yeah.
So how many number of shells are here? As you can see, only 2.
2.
Okay, so number of shells are 2. Clear? Which means every period, first period has only 1 shell, second period has how many? 2 shells.
2.
Third period will have 3 shells. Fourth period will be called as the long period. It will have how many? 4 shells. Fifth period will have 5 shells. Sixth period will have the 6 shells, and seventh period will have the 7 shells, which is the longest period. Seventh period is the longest period. Clear? You can look inside the book as well now. Okay, because if I will write everything, it will take a lot of time. Okay.
Yeah.
Now, clear about this?
Yeah.
Now let's talk about the periodicity. Our next heading is periodicity. Now what do I mean by periodicity? Periodicity means repetition. Okay,
Yeah.
after a regular interval of time, which means that the properties of the elements will reappear at regular intervals. Okay.
Yeah.
So this is called as the periodic properties, and this phenomena will be called as the periodicity. So if someone asks you like what is a periodicity, so how you will say the properties that reappear, that reappear at regular intervals. How many intervals? Regular intervals. At regular intervals. Okay. Or in which there is gradual variation. In which there is gradual means little, slow variation. In which there is gradual variation. Okay, that is
Yeah.
increase or decrease. Okay, at regular
Yeah.
intervals. At regular intervals are called periodic properties. Okay, are called periodic properties, and the phenomena is known as periodicity of elements, and the phenomena is known as periodicity of elements. Okay, periodicity of elements. Clear? This is called as the periodicity, which means that the regular trends, which means regular reappearance after regular intervals, reappearance of the properties will be there. Okay, inside the elements, or there will be some slight variation. Okay, that is called as the periodic properties, and this phenomena is called as the periodicity. Okay, and why this is the why there is the periodicity? Because you know the elements, okay, some elements they have the similar electronic configuration. Okay, which means same electrons, same number of electrons in the outermost orbit. Okay, clear?
Okay.
Now I am writing here
Yep.
the cause of periodicity is the recurrence. Very important points which I am writing right now. Recurrence of similar electronic configuration, that is having same number of electrons in the outermost shell, having same number of electrons in outermost shell. Clear? This is the periodicity.
Yeah.
Okay, now
Yeah.
because electronic configuration will be similar. Okay, now let's start. Because chemical properties first of all depends upon the number of electrons in the outermost shell. Okay, that is the reason why elements of the same group have the similar properties. For example, just look at the group 17. Okay, for example, group 17. Group 17 was also called as which group? Halogen group. Group 17 also
Yeah.
called as the halogen group. Halogen group. Okay, and what are the elements of inside this group? fluorine, chlorine, bromine, iodine, right?
Yeah.
These are the elements which are there. Okay. So now if you look all the halogens, they have how many electrons in their outermost shell? Tell me.
Uh.
See,
A.
just look at this. Fluorine, then we have chlorine,
Yeah.
then we have bromine, and then we have iodine. Okay. Now just look here. I'm sharing you this. See, we have this fluorine,
7.
chlorine,
Yeah.
bromine, and then iodine. Okay, then we have others as well, astatine. Okay, so don't consider these actually. Okay, just consider these above four: fluorine, chlorine, bromine, iodine. Okay, now fluorine atomic number 9 is fluorine. Okay,
Yeah.
chlorine is atomic number 17. 35 is bromine. 53 is iodine. Okay, atomic number 53.
Yeah.
So if you will consider the the electrons in the outermost shell, you will find that there are 7 electrons in the outermost shell. Okay, all of these metals have, all of these elements have 7 electrons in outermost, 7 electrons in the outermost shell. Okay, which means they have the similar electronic configuration. Okay,
Yeah.
it doesn't matter whether the number of shells are higher or lower. It doesn't matter. The thing is that the outermost shell should have the 7 electrons. That's it. Okay, so 7 electrons are there in the outermost shell. Clear?
Yeah. Yeah.
7 electrons. Now what we can infer from this, since the electronic configuration is same. Okay, electronic configuration is same, therefore their properties will be, there will be, either they will be similar or there will be some slight variation, gradual variation. Okay, so what we can infer from this, so group 17 elements, they show similar properties. Okay, like number 1, what they show, they are non-metals, colored non-metals. They are colored non-metals, colored non-metals, number first property. Okay, all of these, they are non-metals first of all and are colored non-metals. We know very well, because they have the 7 electrons in the outermost shell, which means they are non-metals. Yes or no?
Yes.
Okay, now another property which you can guess, because they have the 7 electrons in their outermost shell, they will form negative ions, right? Because they will, what they will do, they will try to attract the electron, right? That is the reason why
Yeah.
they will form a negative ions carrying a single charge.
Yeah.
Okay, they form negative ions, negative ions.
Can you share your, like,
Yes, yes,
your,
they form negative ions
yeah.
carrying a single charge, right?
Yeah.
Single charge. Okay, for example, let us say, which is the example, chloride ions, Cl minus ions. Okay,
Yeah.
and you may have heard that halogen groups, okay, the elements in the halogen group, they are very reactive. Okay, fluorine, chlorine, bromine, iodine, they are highly electronegative, they are very reactive, right?
Yeah.
So the elements of halogen group, they are very reactive, they are very reactive. Okay,
Yeah.
they are very reactive, then, and are found in combined state. Let us write one more point, and are found in combined state. Clear?
Yeah.
Combined state. Then number 4th property, number 4th is they are slightly soluble in water. They are not highly, slightly, very less, they are slightly soluble in water. Yes or no?
Yes.
But are highly, you know, soluble in organic solvents. highly soluble in organic solvents. Okay.
Yeah.
They are good oxidizing agents. Clear?
Yeah.
Now let's discuss about, since we have discussed about this, now we will be discussing about the important periodic properties. Okay.
Yeah.
Important periodic properties. Important periodic properties. Okay, so what are those important periodic properties? So we will look at that. Number one is the atomic size. What? Atomic size, or we also call it as the atomic radius. Clear?
Yeah.
Then we have metallic character. Number second, we have what? Metallic character. This is also important periodic property, character. We will see what happens to the metallic character when we go down the group, when we go along the period. Metallic character. Okay. Then we have number third, non-metallic character. We will also see non-metallic character. We will also see what happens to the non-metallic character along the period and down the group. Then we will look at ionization potential. Number fourth. So these are the important periodic properties which we will look at. Ionization energy, also called as the ionization potential. The same word. The meaning is same for both. Okay, ionization energy or ionization potential. Electron affinity, or we can say electropositivity. Electron affinity, or next is electronegativity. What? Electronegativity. Clear what I am trying to say? These are some of the properties which we will look at. Okay.
Okay.
Okay, so first of all, very first property is what? Atomic size. We will be discussing about atomic size. Okay, now what do I mean by atomic size? So if I look at the atom, okay, atom basically it has what? It has a nucleus, right? It has the
Yeah.
nucleus, okay, and then nucleus, it obviously has the center. From the center to the towards the shell we have the atomic radius. Towards the last shell we will have what? Atomic
Yeah.
radius. So it is the distance between the center of the nucleus of an atom and its outermost shell. For example, suppose I have an
Yeah.
element like this, okay, and this is the shell. Suppose this has two shells, right?
Yeah.
Two shells. Okay, I'm drawing like this, but let me take the this figure. Okay, suppose this is what? Okay, now let's take one more. Okay. Alright, so now this is the nucleus. So from its center, from the center of this nucleus towards this outermost shell, this will be considered as its radius, atomic radius. Clear?
Yeah.
Atomic radius. Okay, because this is the nucleus which we have. Nucleus. And then we have the inside in the center of the nucleus, from the center of this nucleus towards this outermost shell, this will be called as what? Atomic radius. Clear?
Yeah.
Okay, so I can write a definition. What is atomic radius? If someone asks you what is atomic radius, just tell them it is the distance between the distance between the it is the center of the nucleus of an atom, center of the nucleus of an atom and its outermost shell, and its outermost shell. Clear?
Yeah.
What I'm trying to say? Okay.
Yeah.
Now suppose there are two molecules. Okay, like this. Suppose we have the two molecules like this. Number one molecule is this, and let us say another molecule is this. Number one molecule is this, and let us say I'm drawing with the pen. Okay, another molecule is this. With the help of pen, it is not easy to draw the accurate figure. Okay, so these are actually, as you can see, they are combining. This it's a molecule. Okay, because two atoms are combined together. Okay, suppose these two atoms are combined together. So this will be their nucleus and this will be their nucleus. Okay, and
Yeah.
the distance between these two nucleuses. Okay, this is internuclear distance. Internuclear distance, and the distance between these two nucleuses actually, okay, is the what? Atomic radius. Okay, atomic radius can also be defined as half the internuclear distance. Okay, so the half of internuclear distances is called as the atomic radius. Clear?
Yeah.
So internuclear distance, the half of this internuclear distance is called as the atomic radius. Okay, half of
Okay.
internuclear distance is called as atomic. If they are talking about a molecule in which two atoms are combined together. Okay,
Yeah.
atomic radius. Clear about this?
Yeah.
Now what is the unit actually to calculate atomic radius? So there are two units which we use mostly. Okay, number one is the angstrom. So unit, number first unit will be angstrom. Angstrom, which means 1 angstrom is how much? It is represented like this. 1 angstrom equals to 10 to the power minus 10 meter. Clear? And another is
Yeah.
picometer. Pico means 10 to the power minus 12. Picometer. Picometer. So 1 picometer, 1 pm equals to how much? 10 to the power minus 12 meter. Atomic radius. Okay. Then atomic
Yeah.
radius, on which factors atomic radius depends? Can you tell me? Atomic radius factors. There is another heading. Factors on which atomic radius depends. Factors
Yeah.
on which atomic radius atomic radius depends. Can you tell me what are the factors?
Uh, Number of shells.
Very good. Number of shells. So larger the number of shells, more will be the atomic radius, right? Because the distance will
Yeah.
be increased from the center of the nucleus, right? This
Yeah.
means that an increase in the number of shells increases the size of an atom, because the distance between the outermost shell and the nucleus increases. Okay? Clear?
Yeah.
And another factor,
Uh, Better.
nuclear charge. Increase in the nuclear charge. Okay? The charges inside the nucleus. Nuclear charge. Okay? So basically when there will be increase in the nuclear charge, the size of an atom will decrease. Okay? Because more
Okay.
electrons will be attracted towards the nucleus with greater force. Okay?
Yeah.
That's why. So number first is number of shells. Number of shells. Okay? Number of shells. You said it right in the beginning that larger the number of shells,
Larger.
number of shells, more will be the tell me, more will be the atomic
Radius.
radius or atomic size, atomic radius of an atom. Why? Because, tell me, because
It's the distance between
yeah,
the
the
nucleus.
distance between the center of nucleus and outermost shell increases. The distance between center of nucleus and outermost shell increases. Clear about this?
Yeah.
Increases. And then we have number second, very important. After number of shells, what we have? Increase in the nuclear charge. Okay, it also depends upon the nuclear charge. Okay,
Yeah.
nuclear charges present inside the nucleus. And what are the charges present inside the nucleus? Protons and neutrons, which means that when the positive charge present in the nucleus of an atom will increase, okay, which means what will happen when the increase in nuclear charge will be there will be increase in the size of the atom, decrease in the size of atom.
Yeah.
Okay, so an increase in nuclear charge decreases the size of the size of the atom. Why? Why? Because the electrons tell me, are then attracted towards the nucleus? Attracted towards the nucleus, okay, with greater force. Clear?
Yeah.
Okay, and this will bring the outermost shell closer. Okay, bringing the electron will actually the atom will shrink, try to shrink, bringing the outermost shell closer to the nucleus.
Yeah.
To the nucleus. Clear about this? Okay.
Yeah. Okay.
So what's going to happen when we will go down the group? So trends in atomic size. Let's discuss one more heading and then we will wrap up. Okay. So now trends in atomic size. Atomic size. Or we can say atomic radius. Clear? Atomic
Yeah.
radius. So what will happen when we will go down the group? Okay. So when we go down the group, okay, so down the group, let's say down a group. So what we will see? So when we go down the group, just look at this table. When we go down the group, what happens? See, number of shells increase, right? Hydrogen.
Yeah.
Then we have lithium. Hydrogen has only one shell. Lithium has two, Kl. Then we have KLM, KLMN, right?
Yeah.
So these will increase, right? Number of shells are going to increase. This means when the number of shells increase, what will happen? Tell me.
Nuclear. The atomic radius increases.
Yeah, the atomic radius will increase when we will go down the group. Okay, so the atomic size or the size of an atom increase as one proceeds from top to bottom. In a group, the size of an atom increases as one proceeds
Can you share? Thank you.
from top to bottom. Okay,
Yeah.
top to bottom, because number of shells are increasing as
Yeah.
number of shells of an element increases. Okay,
Yeah.
the rest of the reasoning you can write by yourself. Okay, I don't need to write that because I have already explained you everything. So for example, let me give you one example. For example, I am taking hydrogen. Okay, for example, here I am taking hydrogen, group number 1, hydrogen.
Yeah.
Okay, and the same group, hydrogen, represented by the element capital H, atomic number is 1. Okay, and the second is lithium. Okay, represented by the symbol Li. Lithium represented by the symbol Li, atomic number is 2. Clear? 2.
Yeah.
Now, and its atomic number is 1. So hydrogen, how many K shell? Electronic configuration, let's write electronic configuration. How many K shell is there, which means 1 electron in K shell? And lithium, atomic number 1 hydrogen, atomic number 2 helium, atomic number 3 is lithium. So it is atomic number 3. Okay, atomic number 3 is lithium. Okay, so K shell is how much? K shell, I'm writing here, let's rough this. K shell,
2.
electronic configuration, K shell and L shell, 2 and 1. How many shells are there? See, 2 shells. So if I will draw the atomic structure, so this is the nucleus, okay, and this will be the K shell, and here we will have 1 electron in this K shell, outermost shell. Okay, now obviously if I will draw another one, okay, like this, for lithium, this is the nucleus of the lithium, then
Yeah.
2 shells, Obviously it is looking bigger, yes or not?
Yeah, it is.
Okay, so two electrons are here and one is there in the outermost shell. Okay, clear?
Yeah.
So down the group when we will go, what will happen? Atomic size will increase. Okay,
Yeah.
but there is some exception as well. Okay, for example, fluorine basically. Okay, so we will look at the exceptions later. Okay, otherwise we will get
Okay.
confused. Now across the period, when we will go across the period, what will happen? Tell me. Nuclear charge increases, right? Number of electrons will increase, yes or no?
Yes.
Nuclear charge will increase, atomic number will increase in the same period. And when the atomic number will increase, what happens? Size decreases. Clear? So across the period when we will go, size will decrease. Clear about that?
Yeah.
Any problem so far?
No.
No. Okay. So this is it for today. We have discussed so far a lot, and in the next class, what we are going to discuss, we will be discussing the metallic character. What happens to the metallic character? What happens to the non-metallic character? Okay, and then we will be discussing about like chemical reactivity related to some such certain elements. Okay, so these will be the things which we
Yeah.
will be discussing, ionization energy and all of that in the upcoming class. So in
Okay.
the upcoming class, this chapter will be completed. This chapter is approx 70% completed now. Okay,
Okay. Yeah.
in the next class, this will be completed. This chapter total. Okay.
Yeah.
All right then. So it was really a very good class with you. Let's meet in the next class then. Thank you then. Have a nice day.